In today's video, we are going to prove u1 plus k1 is equal to u2 plus k2, where the mechanical energy of this object at this height is equal to the mechanical energy of this object at this height. Mechanical energy is basically potential energy plus kinetic energy. We are dealing with gravitational potential energy here for potential energy, and the kinetic energy is the normal kinetic energy that we all deal with, half mv squared. So yeah, that is the kinetic energy, and yeah, u is represented as gravitational potential energy, or you can say potential energy. In this case, we are talking about gravitational potential energy, where the only force acting on the object is mg. So we said this mathematical statement by saying the principle of energy conservation, where energy can neither be created nor destroyed, only transferred. So that means in a system, the net energy is basically the same. Energy can't be created or nor destroyed in the system. It can be only transferred from one to the other. That's all. That's it. So is it true? In this case, can we prove that mathematically? Yes, we can prove. So let's prove with this mathematically. It's pretty cool. It's basically by knowing the fact that work is force times displacement, where it is k2 minus k1. Basically, the kinetic energy, like the after kinetic energy minus the initial kinetic energy, that is basically n2 minus k1. This is the final kinetic energy, and k1 is the initial kinetic energy. So by knowing this fact, you can prove this. That's pretty cool. It's just basic algebra. And the force of our object, the net force, is basically mg. We know the net force, that is mg, that is force of gravity. So we can substitute for that. That is mgs is equal to k2 minus k1. And yeah, and we can also write u is equal to mgh, if anyone is wondering again, and k is half mv squared. All right. By the way, I'm assuming that you all know what is gravitational potential energy and kinetic energy. Okay, so with that, let's go ahead and prove it. Let's see. There's a work done for our object, but what's our displacement? Displacement is basically h1 minus h2, right? This is h1 minus h2, right? Yeah, so that's the displacement of our object from here to here. So let's write our new displacement. This displacement is equal to h1 minus h2 is equal to k2 minus k1. Neat. Let's distribute mg to all into the bracket. That will be getting mgh1 minus mgh2 is equal to k2 minus k1. Alright, so we know that mgh1 is basically u1 and mgh2 is basically u2. Like, if you know how gravitational potential energy works, you know that is u1 and u2. You know the height, like I'm not explaining, I'm pretty sure you know this, because you can't get to energy conservation without learning gravitational potential energy, like proving this, right? So I'm assuming that you all know this. So mgh1 is u1 minus u2. Yeah, okay, so that's mgh2 is u2, and that's is equal to k2 minus k1. Okay, we got everything we need to prove this, every single variable. All right, so let's put u2 to this side, and let's put k1 to this side. So assuming that you know basic algebra, you will finally get that u1 plus k2, sorry, not k2. All right, k1 is equal to u2 plus k2. I don't know why there is this, because that's not anyhow equal to work. Sorry, this is not equal to work. All right, so that's it. We proved it. The mechanical energy, the total energy of this object at this height, which is equal to the total energy of this same object at this height. So, and the total net energy is conserved in the two scenarios, assuming these are the only two energies on the object and with one force, which is the force of gravity. All right, let's do an example to make it into your brain. So this is our question example, where my object is moving at 10 meters per second in this like in that frame, and it is above, like from the ground, it's about like 40 meters from the ground. And the second case of our object, after traveling in this way, it is having height 0 meters from the ground, and it hits at some velocity 2. This is our velocity 1. Okay, that's our velocity 1. Amazing. So we have to find velocity 2. Yeah, this looks pretty complicated, that it's going in a curved path, but if you know gravitational potential energy, it doesn't depend on the path taken. So without even wondering how it's going with this complicated curved path, you can just say u1 plus k1 is equal to u2 plus k2, and you can get the answer, because gravitational potential energy doesn't depend on the path taken. I'm assuming that you know. I is the reason. Okay. What is U1, which is mgh1 and plus mv squared 1 by 2. That's the speed of our object at this case. And yeah, so the v in kinetic energy doesn't talk about the velocity, it's about speed. Okay, it's not velocity. All right, I confuse that sometimes. V here is speed. Okay, so mgh2 and plus mv squared 2 by 2. All right, that's by 2. Now, so this is this v we have to find. Okay, we can see m is common, so we don't even need to think about m. So let's multiply everything by 1 by m. So m can easily be cancelled out, so we'll get gh1 plus v squared 1 by 2 is equal to gh2 plus v2 the squared by 2. Let's just put the values. G is 10, G is given, the value is 10. Everything is in SI units, so we don't need to worry about units. We can, at the last, we can put units. Okay, cool. So that's cool. I should put the values. So G is 10, h1, the first, in the first case, first h1 of the object, the first case, it's 40 meters. So 10 times 40 will get 50. Sorry, not 50, 10 plus 40, right? 10 plus sorry, it's not 10 plus 40. What's happening? All right, 10 times 40 is 400, and v1 squared is basically 100. Like 10 times 10, 100. 100 by 2 is 50, and gh is gonna be 0, because h, the final h of our object, is 0 meters from the ground, and we don't know this variable, so this variable should satisfy this left hand side. Okay, that's cool. So 400 plus 50 is basically 450 is equal to v2 squared by 2, and 450 times 2 is 900, right? So if I multiply everything by 2, cut, we will get this as 900 is equal to v2 squared, the velocity, sorry, not the velocity again, it's the speed. We will find the speed, so let's square them, like let's put them under the square root. Square and root will get cancelled out, so we are left with the variable that we need to find, and the square root of 900 is 30. You might say there is minus 30, but speed is only positive, so we will reject the minus value. So we will find that v2 is equal to 30 meters per second. So that is the answer. So I hope that you understood with this example, and I'm hoping that you solve this without me solving at the first glance. So yeah, that's all. This is the example, and you can do multiple questions relating to this. I hope you find this on the internet. So yeah, that's all. Thanks for watching. Bye.